All right. Hello, everybody, and welcome to class. So we ended yesterday or the previous session, and we were talking about the importance of firewalls. And I really like this lab because it's a very, very basic conceptual lab, but what it actually highlights is incredibly powerful for understanding how attackers move laterally within an environment. So what we're going to do is we're going to open up a Kali instance on our system. I'm going to accept this little warning that it has here. There we go. Good sized font on that today. I kind of messed with my screen resolutions. Like it looks good, looks good, looks good. And then we're also going to bring up some command prompts and things like that as well so we can get our IP address. So we're going to start by running ipconfig on our Windows computer system. So we're going to right click. Oh, wait, right click is different in KDE Plasma. There we go. Right click, copy. That is not what I wanted, but we'll see if it works. So we're then going to open up a standard command prompt on our Windows computer system, and we're going to paste that in. And that did not work. It looks like my copy and pasting is doing really weird stuff. Here we go. I'm going to get it this time. I swear. There we go. Copy. Now we go right click, paste. There we go. ipconfig. And I know it would have been faster for me just to type in ipconfig. And that's an absolutely true statement. No question. But I'm going to slide that over here just so I have my Windows IP address. Next, what we're going to do is we're going to scroll down and we are going to start up Kali. And we're going to do a very, very, very basic Nmap scan against that system. So I'm going to right click. We're going to copy that. And we're going to go over to our Kali system. We're going to become root on our Kali system. And then we're going to run Nmap against our Windows computer system. And we're going to spend a little bit more time looking at this. We got 10.10.204.215 is our Windows system. We're going to kick off that scan. And if at any point you want to find out what is the status of the scan that you're currently running, you can hit the space bar. And it says, hey, I've got one system that's up. It's undergoing a SYN stealth scan, and it's about 73% done, and it gives you an ETC, and it comes back and it says, here's all the ports that are open on this computer system. We got 135, 139, 445, 3389, and 53757. Now let's go through these. If we're looking at 135 and 139, those are our NetBIOS ports and our remote procedure call ports. So let's talk a little bit about what remote procedure call is. Also, you have Microsoft data services. They're all basically ways that Windows computer systems can communicate with each other. A long time ago, far, far, far away, once again, in the land of cocaine that Microsoft brought us, there was a lot of conversations, and some of them were really cool conversations about computing. One of the earlier conversations was a network of a bunch of Windows computer systems would be able to be used together, and they could expose the core components of the operating system via RPC or remote procedure call so that you could communicate and collaborate with a number of different Windows computer systems together. In short, the network of systems would be the computer. Now, this is awesome. Having all these computer systems collaborating, doing math, doing all of this stuff, working together. Super awesome. Sounds like a great idea. Horrible, horrible, horrible idea. A really incredibly bad idea for a wide variety of different reasons. One of the first reasons is the authentication protocols between Windows computer systems is actually clear text. Let me explain that. Whenever one Windows computer system is talking to another via LAN or what we call NetNTLM and NetNTLM v2. It takes the password hash of that system and it sends the hash with a little bit of encoding. It's usually just a little bit of randomness that is sent clear text, by the way. So it's usually like a 16-byte challenge of, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. Don't ever use that one. That's a whole nother series of problems. But 16 bytes sends it to the client system. The client system wraps their password hash with that 16-byte challenge and then sends the password hash back across the network. Couple of problems with this. The first problem with this is the challenge is sent clear text and the response is sent ciphertext. The protocol is known. There's no randomness. You can reverse it. So if you're on a Windows network, you have the ability to actually sniff and reverse engineer any of the password hashes that are being sent. That works for LAN-MAN and NetNTLM v1. The only difference between those two protocols is the LAN-MAN hash is set for LAN-MAN and the NT hash is set for NetNTLM v1. When you get to NetNTLM v2, there's a whole bunch of other randomness and things rolled with it, but it can still be reversed out. Now, the problem with this entire thing is it's sending the password hash back and forth clear text, and the validation is only on the password hash itself, which means the systems are using the password hash as authentication. So you don't even need to know what that actual password is. As long as you have the password hash, you can authenticate utilizing those protocols. So that in and of itself kind of is a bummer, right? Number two, with RPC, if you remember all the vulnerabilities that came out with Microsoft, like 03026, 05029, all of these different 08067, we have all of these vulnerabilities for Blaster, Nachi, Welchia, and Conficker was another one. Sorry for those of you that are in Germany, apologize. And the problem was Microsoft with RPC is exposing its entire operating system API to systems on the networks. So you're not just talking about protecting the operating system via SSH, like remote authentication. You're talking about protecting all of the different remote procedure calls or in-process communication shares that are inter-process communication endpoints, named pipes, that are exposed to the network itself. So that's one of the big problems that you have with Windows, right? And in this situation, all of those ports are exposed. RPC, NetBIOS, SSN, Microsoft DS, all of that is exposed to the open internet. Now, you may be asking a so what question, and that would be a very good question. Why do I care? Why does it matter to me? And we're going to show you why that matters here in just a couple of minutes, so we can see those ports are open. Now, what happens is if I go over here and I run netsh ADV firewall, set all profiles, state off or on, let's turn on the firewall. That changes the entire view of this Windows computer system dramatically. Because now if I'm actually doing a port scan of this computer system, you can see that it still can identify that that particular system is up and running. However, now the only ports that are open are Microsoft WPT server and WSDA API. And the reason why those two ports are open is it's required for Guacamole to work on those systems. So there's firewall rules explicitly allowing those particular ports coming into this computer system. But you can see those Microsoft kind of internal type ports, data services, NetBIOS name services are removed, remote procedure call. I can't see those core protocols that allow me to authenticate and do bad things to a Windows computer system. So I can do this. I can now set that firewall off, and now I can run a port scan of that computer system again. All right. So it's going to take a couple of seconds, and it's going to pop up, and it's going to say those ports are back open, and I'm going to show you what are the bad things that can happen to a computer system if those ports are open and accessible. So we played with all of that. So now what we're going to do is make sure that our antivirus is off. So I'm going to do set MP preferences. We're going to disable real-time protection. We're going to set that monitoring. Oops, I keep forgetting. I switched over to Fedora during this class, and that in and of itself isn't that big of a deal. But I switched over to Fedora, and yesterday I was using KDE. Yesterday I was using GNOME, and today I'm using KDE. So I'm kind of getting used to some different things. So we're going to paste in that, give it the E. We're going to make sure that antivirus is disabled. And now we're going to show you what an attacker can do if they gain access to a password. So once again, we're going to set the user of the administrator account. We're going to set that password to password1234. Just going through here. We're going to set that up there. There we go. And now we're actually going to break into this Windows computer system in a different sort of way. So let me move all of the stuff back to where it needs to go. And let's talk about that. Let's do MSF console -Q, like so. And now let's talk about what we did in the previous sections, and let's talk about what we're doing right now. So the first things about this is yesterday we were mounting a remote share on a Windows computer system, uploading and executing our malware. which is an incredibly effective way to go about trying to compromise a Windows computer system, right? Gave me an opportunity to show you how we're generating malware, what an executable looks like. You can actually run that executable, explaining the different commands, explaining the reverse handler, explaining all of those different things. But today we're going to be doing it different. Today, what we're going to be doing with this system is we're going to be authenticating to that Windows computer system, and we can authenticate in a couple of different ways with that Windows computer system. So I'm going to show you how we do that utilizing a wonderful little module that's used in Metasploit called PS-exec. So let's go back to full screen on the lab. Here we go. So now let's get started. We got MSF console is up and running. I'm going to get my my IP address on my operating system, my Kali system. I can do that. Copy that. We'll go copy. And we're going to paste that in like so. One of the cool things about Metasploit is if it receives a command that it doesn't understand, it automatically feeds it into the operating system, which is neat. So I can see that IP address right there. Next, what I'm going to do is we're going to set the R host to be our Windows computer system. Or we're going to use exploit SMB PS-exec. Okay, we're going to use exploit Windows SMB PS-exec. Copy that. I'm going to paste that in over here. Takes a few moments. We're going to set to, well, you can see the default is Windows Meterpreter Reverse TCP. That is the default. So we do not have to put that in, but it is the default. We're going to set the R host to be our Windows IP address on this system. I'm going to copy that, and we're going to paste that in over here. We're going to set that R host to be 10.10.204.215, like so. Then we are going to set our L host to be our Linux system, our Kali system. By the way, L host doesn't stand for Linux computer, it stands for local host. And that's for the reverse connection coming back, just kind of clearing up some confusion that people get into every once in a while. I'm going to put in 10.10.241.90. That's my Linux computer system. That's my Kali computer. We're going to set the SMB user to be administrator. Copy, paste that in. And then we're going to set the SMB pass to be administrator. Now, I'm going to come back to SMB pass here in just a couple of seconds because that gets kind of cool here in a few moments. There we go. And then I type exploit. Now, there we go. So now we're just authenticating to that Windows computer system. We're creating a new service. That service is then executing, and then we get a full interpreter session on that Windows computer system. Now, I want to show you a couple of additional things, possibly. Let's do hash dump. Run hash dump. And there we go. Let's see if I can do this. Let's do some off-roading and see if this actually works. So what I'm going to do is I'm going to take this right here, and I'm just going to get the password hash, right? So let's say I get access to a bunch of password hashes on the network. Let's see if I can make this work. We're going to go copy that. I didn't want that though. Let's go Control C. Let's do exit. There we go. And then I'm going to set the SMB pass. Instead of the SMB pass being password 1234, you can actually take that administrator account. And then I can copy that. Oh, I don't want that colon. I only need one colon. This command has 2 colons. It's of no use to me. There we go. There we go. There we go. Let's see if this works. There we go. All right. So what actually is going on here, right? You can see that we can authenticate to that particular computer system, and we can authenticate to that computer system as the, whoa, that's weird. Let's try that again. Oh, you can see the authentication happening. Did it turn on its firewall? All right, there we go. that's looking better. There we go. So here's kind of the mind-blowing thing with this, right? With Windows operating systems, if I know the password is password1234, I have that ability to actually set up a scenario where I can log in with that password using ps-exec. We're using built-in Windows commands to authenticate to that system because ps-exec was a utility and kind of a protocol established by the fine folks at sysinternals. We talked about Mark Rasanovich in earlier sessions. But in addition to that, and probably more terrifying than that, if I can just get a password hash, I can authenticate to a Windows computer system without even knowing what the password itself is. All right. I can do that without even knowing what the password itself is at all. So if somebody has a password hash that is really, really, really strong, let's go ahead and try this. Let's do password 1234. And I'm just going to type in a bunch of gibberish here. All right. So is that password what you would consider to be a strong password? Like if we were going to try to crack that password, how long would it take to crack that password? And that's a long password, folks. Let's be honest. Think about that, right? So we're looking at it. Each of the different characters that you add to the password is going to double the total amount of key space and the amount of time associated with it. And I was going to be blunt. It's probably heat death of the universe type password. If somebody could look up what, just kind of sit down and think about, jot down, what is the heat death of the universe? Something like 1 trillion years or 100 trillion years. I don't know. It's a long time. It's a number that's so big, it doesn't even matter to me. It's huge, right? So if somebody has a password like that, I can still do hash dump like so, and I can get that password hash for that administrator account. So if I go up here, you can see that the administrator's password hash was D4A1BE. And you can see down here, the administrator's password hash is now 493232C2E6, right? So I don't even have to crack that particular password at all in order to gain access to this computer system. So I'm going to exit out. There we go. And we're going to reset that SMB pass. Instead of it being the password or even being the old password that it was earlier, we're now going to set that to be the password hash for the stupid long password that I just set it to. There we go. And then we can exploit. All right. Watch this whole entire thing just go away now. Oh, we authenticated. There we go. All right. So even though we have a password hash that is stupid, ridiculous long, right? I can actually take advantage of the way that Microsoft does its authentication by taking advantage of the password hash being sent literally as though it is, in fact, a clear text password. And I can do a pass the hash attack to be able to authenticate to that Windows computer system. How scary is that, right? That is terrifying. So this gets back into the compliance standard stuff that we were talking about on day one, or in the first section of this class. You have all these audit compliance standards, and a lot of those compliance standards will say things like, thou shall not use clear text authentication. SMB is a clear text authentication. It's just at some point, it changes the way it looks at passwords. Instead of authenticating you based on your password, it's merely authenticating you based on the password hash. And it's never checked on that as well. So there's some questions that come out with this, right? There's some questions that are commonly asked. Like number one, holy crap, does Microsoft know about this? The answer to that is, yeah, Microsoft knows about this. This has existed since 1997. Oops, Brian, your mic is hot. Editors, gonna have to cut that out. There we go. So when you're looking at this, this is bad, right? This is bad. Number one. Number two, another one of the questions that I get all the time is how do we mitigate that? And I'm going to show you how we mitigate that here in a second. Kind of some crazy stuff. And then one of the other questions I get is this is for SMB authentication, LANman, NetNTLM v2, and all of those different things. What about Active Directory? Well, it turns out with Active Directory, it's even easier because with Active Directory, you do token impersonation where you get the domain token for the user and you still do not need to know what the password is because you have an authenticated domain token for that system, right? You have an authenticated domain token for that particular computer system. And once again, you do not need to know what the actual password is for that computer system as well. Now, some people are talking about these like, oh my God, this password hash thing is rough. Look, there are only two password hashes that are stored on a Windows computer system. Only two. Right here. This password hash right here, this one, you can see where it's that AAD3B4, right? That is the landman password hash. That is a DES encryption utilizing the password as a key to encrypt the string KGS exclamation point at pound prompt $. That is landman. It's horrible. It's insecure. And you can see for all the password hashes, it's the exact same landman because it's blank. Microsoft stopped storing that. After that colon, however, you have this password hash, which is the MD5 password hash. That is a straight MD4 hash of the password. So when I typed in that big long gibberish string, it's just MD4 hashing it and it's going with it. That's it. Super easy. Those are the only two passwords that are stored on a Windows computer system. If you were anybody talking about like NetNTLM and NetNTLM v2, those are not password hashing algorithms. Those are authentication protocols that Microsoft used. Also, Kerberos is another one as well. And there's other things in here as well. Some other modules we don't have a lot of time to go into. Let me see if I can find some of them. You also can use Gentle Kiwi's Mimikatz in here as well. So you have Mimikatz in there, but there's so many different things. So if I do run and I hit tab, watch this. Post-exploitation modules in Metasploit, there's 581 of them. These are all of the modules that you can run with Metasploit post-exploitation to exfiltrate data, elevate privileges to administrator, pulling down session identifiers, gathering more information for different computer systems, dumping password hashes, pulling all of these different things. It is insane. All right. So we got to get off of this, but I want to show you one last thing, kind of tying it back to the point of all of this. How do I make this entire problem go away? Easy. You don't trust the network. Don't trust the network because the network is hostile. Always treat your network as hostile because it is. Because as soon as I turn on that firewall, I try to exploit that computer system, my entire session and my capability is dead. That shuts down that post-exploitation lateral movement that attackers take advantage of all the time. Make sure your systems don't trust the rest of the network. I cannot stress this enough in your environment. All right, so now we're done with that lab. I am going to destroy my VMs. I'm going to destroy the labs because I want to recreate those here in just a couple of seconds. I'll let that run. There we go. And now I'm going to go back to the slides. There we go. And let's keep going. There we go. All right, let's do it. Internet allow listing. So internet allow listing is really, really, really important. It's very similar to what we were talking about with application allow listing, and it goes all the way back to the beginning of the sections where we were talking about Marcus Ranum and the idea of trying to enumerate badness as a bad idea. And just like application allow listing and utilizing app locker, there are a number of different things that we have to take into mind. And really, when people are looking at application allow listing, or they're trying to look at internet allow listing, they come with preconceived notions right out of the gate that this is hard. It's going to be very difficult to do. You're going to have to go through and set up like some kind of star chamber to authorize every single website that your users are going to go to. And it's really not that difficult. It is honestly just not that hard at all to do. Let's talk about how we actually do this appropriately in environments. So, what are we shutting down with the MITRE attack technique matrix, right? So, we're looking at pretty much shutting down initial code execution. And the reason why we're shutting down initial code execution is because a lot of the C2 servers are on non-recognized domains and non-recognized systems. I'm going to talk about that. We call them uncategorized domains and uncategorized systems on the internet. It's going to shut down command and control. It's going to shut down data exfiltration. It slices, it dices. It is absolutely something that you should be doing in every single environment. But let's talk a little bit about why deny lists fail. First and foremost, the internet is big, like really big. You won't believe just how vastly, hugely, mind-bogglingly big it actually is. And most of it's worthless, right? And evil. And many of your users will not stop clicking until they visit every single website on the internet. I remember my grandmother, she used to click on like links and emails, and that was a bit disconcerting. And I tried to tell her, Grandma, you need to stop. Please stop clicking on links from strangers. And her whole take of it was like, well, it'd be really rude if I didn't. She thought if they went through the effort to send me an email, I really should go through the effort to at least click the link in that email. And I used to think that that was something that was not normal. And it turns out in my career, it's absolutely 100% normal. And that's just the way people are. And you can't develop your entire security support structure around training your users not to click on links because they're going to do it. And honestly, with the right ruse, I can get anybody to click a link. Give me enough time, kind of work through it. I have the capability to try to convince people to do that. Now, the problem with the deny list issue is what vendors are trying to do is they're trying to enumerate all of the bad websites and all the bad IP addresses and pushing out lists to say these are the IP addresses and the websites that people should not go to. And this really gets back to the Ugg and Thug analogy that we talked about on day one. We have two cavemen, one of them saying, hey, eat that mushroom, right? We're not going to eat that mushroom as well. But how do we get around some of this? Well, one of the things that we do at BHIS is a great technique that has some great write-ups from SpecterOps, a fantastic pen test firm out of the Seattle area, some really, really good people. And they kind of wrote up some stuff on techniques that the community has been using for a while, where they basically take domains that recently came for sale that are already categorized, right? So we have a number of different tools out there where you can run Domain Hunter. Domain Gain is one of the tools that we're going to be talking about, where you can check and see what domains are for sale. You can buy a domain that is already categorized in an environment as well. So this is Domain Gain. This is by Full Metal Cache, one of the testers at Black Hills Information Security. And it says, okay, it automatically goes out online and it finds all the domains that are currently for sale. Then it sorts those domains by URL. It runs it through a number of different web scores for risk. So SimWeb and ACR, they check to see what is the risk associated with that domain. Then they resort it. They resort it by score. They sort the results, and then they come back with this. So it says Warrant Navi is already pre-categorized as brokerage and trading, and it's available for $7.65. OregonCityParks.org is available. That one is a government legal website available or domain for $10.79. Reich is entertainment for $10.79. A32, EUBY. We have all these different websites that are pre-categorized and ready to go, which is a lot of fun. Now, let's take that. Granted, we use that as an attack methodology, but I got a question. Like in most environments, I want you to think for a few moments, like how many legitimate websites do your users actually go to in any given day? How many legitimate websites? Just think about that for just a couple minutes. Are your users going to 200 legitimate websites? 500? Maybe it's 1,000. I don't know. Find out, right? If you go to your web proxy logs and you look at all of the websites that users are going to, and then you break that down to what are the websites that are actually business required for us to do business, a third-party SaaS service? Are we looking at individual services that we have on-prem? What do we have on this? And honestly, you're probably looking at less than 200, right? And let's say that we allow all of them. Like all the websites. And I mean legitimate websites like Facebook. Let's say we allow people to go to like Google, Facebook, whatever, and we allow them within reason, but we remove ads. What would be your exposure? I mean, would it be high? Would it be medium? Would it be low? But let's go further. Let's say that we actually allowed the users to make the decisions on their own as to whether or not they could go to a website. Let's say that every website is blocked by default every single day. And the first thing that your users do is when they go to the website is they get a pop-up in your web filter and it says, hey, this is the first time today that anybody's gone to this website. Are you sure that you want to go to that website? You put it in the hands of the user. Would your exposure be greater or less than it is today? Turns out it would actually be a lot less. Turns out it would be a tremendous amount less. The other thing that I want to point out is you can do this relatively easily in your organization without even having to do that. So here's a categorization filter. There's a number of different web proxies that have all these categories. I want you to look at these categories because people go in and they just blanket block a wide variety of categories, right? They're going to block adware, they block alcohol, they're going to block porn and nudity, illegal drugs, mature maybe, maybe nonprofits, I don't know. Politics and law, for the love of God, block that. Religion, absolutely, that's going down. But when you're looking at blocking all of these different sites, there's actually websites that you're going to allow. Maybe you're going to allow your users to go to social networking. Maybe you're going to allow your users to go to shopping. I don't know. Maybe you're a travel company and you need people to go to travel websites. I don't know. But you might have categories that you allow. The one category that you should not allow is this right here, uncategorized. Most of your web proxies have that category. And what that means is if you're running Cisco, you're running Fortinet, you're running Palo Alto, you're running any number of different vendors, it means that that vendor has never seen that domain. Never once. They haven't seen that domain. And if Cisco, Palo Alto, Fortinet have never seen that domain, do you want your users to go to that domain? Think about it. If these big tech titans have never seen that domain, do you want a user clicking that link? Hell no. Absolutely not, right? But let's go one step further. We're looking at these brand new domains. How do attackers do that? What we've seen attackers do, one of my business partners is Chris Brenton, has amazing network threat hunting pay what you can classes. We'll get some links up for you all. You can look at it and you can go to active countermeasures and go to education. You can look at that. But Chris Brenton worked at a very large DNS provider, and that DNS provider saw a huge number of people would buy a domain and then they would basically get a refund within 5 days. And the reason why is by the rules of the internet, if somebody buys a domain, they technically have to have the right to return that domain for a full refund within 1 week. So they were seeing attackers spool up brand new domains, and then they were using them in campaigns and then getting a refund and just doing that again and again and again and again. So when you're looking at this, it allows you to implement internet allow listing in a way that is not horribly oppressive for your administrators and your users. You can allow things like government websites. You can now allow people like finance, entertainment, and videos. You can still block ads. For the love of all that's holy, block ads. Just do me a solid, shut them down. You can allow them to go to a number of websites, but the one rule is if we've never seen a website, we're not going to allow a user to go to that website. So allow listing approaches, allow list every website. That's a dumb idea most of the time. Allow list based on categories, can do that. You can also let the users decide to go to those websites. Some of the proxy software programs that are out there, they will do that. As soon as a user tries to go to a website, it will pop up and say, I have never seen this website. It can be dangerous. We're going to log that you're going to this website. And most users, going back to like Jerry Bantham and Panopticon and people, whenever they know that they're being monitored and watched, change their behaviors in a fundamental way. That allows us to actually start setting up some self-regulation in organizations as well. There we go. Malware and allow listing. No, you can absolutely get compromised through legit sites, right? Drudge Report, Huffington Post, CNN, Fox News, all of these different websites have had scenarios where they have hosted malware in the form of ads, right? But here's the deal. If somebody goes to Facebook or they go to Drudge or they go to CNN or they go to Facebook, they actually news sites, newspaper sites for local newspapers are horrific. Generally, they're trying to get ads. They're going with the skeeviest group of people for ads being served up. If they go to that website, they could get compromised, but usually the command and control server is not the same as the website that the compromise came from. So the compromise is coming from an ad service, and then the actual C2 server is a completely different domain and a completely different system. If you're using that allow listing based on uncategorized, it's going to shut down that command and control from actually being established. We have seen this in a number of organizations that have the exact same uncategorized allow listing approach that we talked about enabled. And what happens inevitably in those organizations is we do find malware, but it's like trying to get to the internet and it's getting blocked again and again and again. And what that does is it buys you time. It buys you time to detect and react to the attacks. So yes, almost any of the different DNS providers, almost any of the different web filtering providers have the capability of doing solid filtering. By the way, OpenDNS, I got called in, my kids, because we were traveling quite a bit. We homeschooled, but when we were home, we wanted them to go to a local kind of school co-op. There was a whole bunch of homeschools, which is kind of a weird mix of people. We had people that were like very, very, very diehard religious, and we had people that were not, and neither of them wanted their kids in school. It was an interesting mix. But I showed up. My kids would go there. They'd hang out with other kids and socialize, which is important when we weren't traveling. And the school asked me, they said, "Hey, we want to secure our network. Is there anything you can do quick and easy?" And I said, "Yeah, we can enable OpenDNS. It's free. I can enable it on your router. It takes me just a little bit to get that set up." And I had it completely set up. And the principal of that school, which wasn't big, it was like 150 students, was like, "Hey, having trouble getting to certain websites. Is there? I don't know exactly what is going on here. Could you look at it?" And I'm like, what types of websites can you give me an example?" And they're like, "Well, just websites." And I showed them the categories. And I'm like, the only categories I'm blocking are like nudity, pornography, hate discrimination websites, adult themes, lingerie. I'm not exactly certain, but I think that this particular screenshot was my initial screenshot for that. And the principal would never come around to telling me exactly what was going on. But I did notice that after about 2 to 3 weeks, they replaced the router, the one that I had configured with this, with a completely different one from Walmart. It was like, wow, that was just uncomfortable and weird. So strange. The other thing that you got to understand is attackers can use, and not just attackers, but users can use DNS over HTTPS. This is one of those things that seems like an absolutely great idea. What we're doing is we're encrypting all of the DNS traffic. We're resolving those names into numbers so people can get to where they need to be. And that's fine, and that's good, and it's wonderful, and it's all of those things. However, under the hood, what you're usually finding out is the people that are running DNS over HTTPS, they're very skeevy as well. They just want to control that sweet, sweet DNS data for the purposes of ads and all of those different things out there as well. So I recommend from an enterprise perspective, don't allow DNS over HTTPS, block it, because you need that visibility for the domains and sites that your users are actually going to. So keep that in mind. All right, let's get into vulnerability management a little bit, talk about how we can deal with this. In a lot of ways, vulnerability management is the exact same as it was 10 plus years ago, right? They're not really changing or modifying with the times at all. They just aren't. They run a scan, they test for external vulnerabilities, and then they move on, and there's very little actual innovation. Now, you do have some vendors that are like, no, 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 we're trying to go through and we're trying to do full analysis and predictive vulnerability analytics, where we're looking at what the attackers are doing in your market vertical, and we're prioritizing the vulnerabilities that the attackers are going after in your market. It's crap. It's lies. It doesn't work. It doesn't work. It doesn't work that way, right? There's this belief in the industry that if you're in retail, that there's a series of attackers that are trying to break into retail providers. And it's like, if we just go after and fix those vulnerabilities that the retail hackers are going after, we're going to be okay. And that's absolute garbage. It doesn't work that way. Never did, never will. Now, what you'll find is attackers will definitely get enamored with a specific attack, specific methodology. You should definitely take care of those vulnerabilities. However, you need to understand that attackers will go after any and all vulnerabilities that you exposed to them. They will take advantage of those vulnerabilities. And it has nothing to do with a specific group of hackers saying, hold on, Roberto, we can't hack into that network with that vulnerability. It's not the same vulnerability that we're supposed to use. We're supposed to use the list of these 100 that CISA has provided to us. Those are the only vulnerabilities that we're going to go after. No, it's not how it works. So what a lot of vendors are doing is they're trying to focus on prioritization. They want to sit down and say, what are the critical issues? What are the issues the attackers are going to go after first? And then they will give those to you. And this is horrible. There's a great quote from Henry Ford, who was like an incredible industrialist. He was an innovator in the age of capitalism and also an incredibly well-known racist. Like, holy crap, Henry. That's wow. At any rate, so he had this quote that I think is great. Because, I got to give credit where credit's due. Sure, he's a racist, but he's got great quotes and started automation. That's nice. But the quote that he has that I love is the quote, if I would have done what my customers wanted, I would have built a faster horse. And I love that quote. And what he means by that quote is whenever he was developing automation, developing the Model T and doing all of those different things, he was creating something that if he was asking the customers what they wanted, they had no idea that they actually wanted. The problem with vulnerability analysis is if you go to many organizations, they will say, what we want is prioritization. We have thousands and thousands and thousands of vulnerabilities. We need to know which of these vulnerabilities we need to focus on first. And that is a valid question. However, what they're telling you is they want a faster horse. You're not giving them the right tools to deal with it appropriately because it creates blind spots like this. So in this particular example, you have a number of different telnet servers, and the telnet banners exist there, right? So let's say I have 1,000 servers that have telnet exposed, and we have seen this, right? If we look at it, we've got login, 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 mushroom, mushroom, login, 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 a router, login, 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 login. What is going on? So we see this exact same thing about twice a year at Black Hills Information Security, where we have thousands of systems that have the same banner again and again and again and again, but one of those says router greater than. Now take a couple of seconds and think about, if you see router greater than, what does that mean? If you don't know, pause the video and look, what does that mean? What that actually means is there's no authentication. There's no user ID. There's no password, straight right into the device. You can take it over. Now, this is a low. And in many organizations, whenever they're focusing on vulnerability prioritization, they're just fixing the criticals and highs in that organization, and they are ignoring anything that's medium and low in an organization. That's all that they're doing. So this will get missed for years, and then we come in and then we exploit it. So the question that you have to ask yourself is, how many organizations actually address the low and informational issues that hit their environments? Very, very few. Very, very, very few organizations will ever address any low or informationals. And many, many, many more will also ignore mediums because they're focusing on the highs, they're focusing on the criticals. So many organizations address vulnerabilities by IP address. This is how they've been doing it. This is how they've been pulling their using their horses to pull plows to their IT fields and saying, look at this field and behold, it is in fact empty, right? So let's use an example. Let's say we have 1,000 IP addresses and we have roughly 25 vulnerabilities per IP address. That equals roughly 25,000 different issues to address. And many organizations will look at those 25,000 issues and they will hand out those issues one at a time based on network range, one at a time or groups based on systems and responsibilities. And then everybody sits down and like, okay, system one, it is missing this patch. System two, it's missing these SSL TLS cipher suites. And they go through it one at a time, at a time, at a time, and it takes forever. So now you can see why organizations would want to have prioritization, because they have 25,000 vulnerabilities to deal with. This approach is almost always wrong. Let me be more blunt. It is always wrong to do it this way. Don't ever do it this way. You're going to get hacked and it's going to be painful the entire time. So what you should do is you should focus on grouping issues by the vulnerability or plugin ID, not the IP address. Not the IP address. Let me explain that. So if you're focusing on the vulnerabilities, instead of having 25,000 vulnerabilities, you're seeing a lot of those vulnerabilities that repeat again and again and again on multiple computer systems. So if we look at TLS SSL cipher suites, if I have a lot of web servers, say I've got a few hundred, and they all have that same TLS SSL vulnerability, that's actually one vulnerability that exists across multiple systems. So me as an administrator, as a security administrator, I can come up with automation techniques to take out that vulnerability across multiple computer systems with one bit of automation across the entire board. Okay? With one bit of automation across the entire board, I can address multiple issues in one shot. So instead of taking each individual 100 issues, I find one way to deal with that one issue that's replicated on most of the systems, and I deal with it in an automated way, right? So we use that automation, and we call this like an open source techniques. And at BHIS, we are one of the few organizations that I know of that has tested 1 million live IP addresses. We've addressed all vulnerabilities with 2 testers in 3 weeks. 2 testers, 3 weeks, all criticals, highs, mediums, lows, and informationals. 3 weeks, 2 people. And when we did that, the company that hired us, they had hired other large pen testing firms that they had brought in year after year after year. And those firms would show up with 5 testers working 2 months, trying to go through 25 million vulnerabilities and categorizing and dealing with them because they were doing it the wrong way. They barely scratched the surface. And when we came in, we would find hundreds of critical vulnerabilities that needed to be addressed by that organization that were not detected by other testing organizations. Because that's the Chicago way, and that's the way you'll get Capone. Sorry, wrong movie reference. But what we're doing here is we're handling it in an intelligent way. All right. Also, when we're looking at the MITRE attack technique matrix, you're really looking at like 2 separate category states. You're looking at exploiting a public facing application and exploiting remote services. Honestly, that's what you're dealing with there. All right. So executive problem statement. How do we go about quickly securing our apps, right? Let's move from general vulnerability analysis and let's talk about web apps, and then we're going to get to a lab here in 10 minutes. Now, when you're trying to deal with web apps, it's very different. Your vulnerability scanning posture is not going to be effective in dealing with your web application scanning. It just isn't, right? Training is very expensive. And by the way, I'm getting less and less cordial about this. I'm just going to be blunt. Training doesn't have to be expensive. You have the Cyber Mentor does amazing training. If everyone could go out on Twitter and say thank you to Heath and Cyber Mentor, do me a favor, go on out and say John Strand and Antisyphon, say thank you for being awesome. I also want you to go to Jerry Auger and Simply Cyber, and I want you to tell him, Jerry, thank you for being awesome. And I want you to go to John Hammond, and I want you to let him know he's awesome as well. See, there's lots and lots of great training opportunities that are out there that don't have to cost a tremendous amount of money to do. I mean, if you want to know what SANS instruction is like if you're paying $10,000, it's this. This is it. This is what SANS instruction's like. This is also what it's like for doing it. Pay what you can. But no, I'm serious. If you all could go on out and you could like Cyber Mentor know thank you for everything that they do from the bottom of our heart, and let John Hammond know, and also Jerry, let those guys know that we think that they're awesome, and we really, really, really appreciate it. Yeah, because if we're looking at like large scale security training, charging $10,000 for something. And by the way, I got a little salty on Blue Sky. You're seeing these types of things where companies are doing more and more training on open source tools and they're making lots of money training people on somebody else's tool and they're not giving back. And that's one of the reasons why we try to give back to the community 10% of what we make in all of our paid classes that goes back to an open source project out there as well. So it doesn't have to be expensive, right? But how do we deal with it? When you're looking at software development life cycles, you're looking at a continuous build. That means that your developers of the applications that you're using, whether they're custom or SaaS apps, they're constantly building and they're improving and they're modifying those applications. And unfortunately, many times, security is just bolted on at the end. This is incredibly expensive. It is also highly dangerous. Security testing should be something that is done throughout the entirety of the process, at the beginning, throughout, and the end. And it doesn't have to be that hard. When you're looking at computer security, the vast majority of vulnerabilities that hit organizations today are vulnerabilities that can easily be addressed and identified with an automated scanning tool. And we're going to have a lab here in just a bit. We're going to play around with one of those automatic scanning tools as well. It's also a different skill set from web developing, but they're very much complementary. And honestly, all of the different tools that are out there really get to the Pareto principle. You can find 80, I actually think this is wrong. I actually think it's 90% of the vulnerabilities can be discovered with 10% of the effort out there as well. All right, where and when to test. It's so easy to use these tools. You should be running them constantly. Every time there's a new build cycle, I would recommend, if you're running a SaaS app, I would recommend going through and, another person that I forgot, and people sometimes bring this up, Network Chuck is awesome. I don't know him. He's like in another stratosphere, but he's very cool as well. All right, so when you're looking at where and when you should actually go about testing, should be everywhere. The tools are cheap, very easy to deal with. And a lot of these tools are excellent for telling you exactly what the vulnerability is and what the class of that vulnerability is as well. Now, what are you going to test for in automated tools? Automated tools are awesome, and they're going to find cross-site scripting, SQL injection, command injection, misconfigurations, and the above attacks are anywhere between 80 to 85% of the vulnerabilities that we see bad people attacking. I mean, they're just out there and they're easy to find, and the tools find those vulnerabilities. Life's good. It's awesome. But do those tools catch everything? No, absolutely not. The automated tools do a great job, and we use a lot of automation at Black Hills Information Security and what we're actually doing. It's fantastic. However, we spend a lot of time identifying business logic errors. We find a lot of time finding permission errors in website, stored cross-site scripting, cross-site request forgery, and many of these vulnerabilities require manual testing. However, a little bit of hope on that. However, with these particular vulnerabilities, we generally don't see these vulnerabilities being exploited in the wild at a high clip. You see a lot of the stuff on the previous slide, cross-site scripting, SQL injection, command injection, all of those different things. You don't see these being exploited quite as much, so you have a little bit more time. So we recommend in any organization, you should develop a solid web application testing process that goes beyond simply running Nessus against your web servers. There's absolute value for running Nessus against your web servers, but there's other vulnerabilities and things that will not be discovered. For example, we talked about the business logic stuff. Also, with vulnerability analysis tools, they're horrible at checking for web vulnerabilities. They're just bad, like Nessus and Qualys and all those. They're not great. It's not really their strength. They really don't do as well as they should, and that's okay. And the reason why that's okay is that there's a whole bunch of other tools that you can use to find those vulnerabilities. And we're going to be working one with Z-Attack Proxy here in just a little bit. We'll be talking about ZAP. Now, these tools are free. You can run them, you can find lots of vulnerabilities, and it's going to clean it up. So when you have a pen tester come into your organization, they're not going to spend a whole bunch of time finding vulnerabilities that can be easily identified with open source tools. And when you do that, it allows your penetration tester to focus on the difficult things. A lot of tools out there, right? Burp Pro is the one that we use. take a couple of seconds, go check out what is the cost of Burp Suite Pro. I think it's like $495 from Portswigger. I'm not exactly sure what the cost is, but it's around $500. Very, very cheap, right? W3AF is another automated web app scanner that's okay. I personally am a huge fan of ATT&CK proxy. We'll be talking about that. Nikto is written by Chris Sulu, who's one of the testers at Black Hills Information Security. And if you know how to use these tools appropriately, you actually can do better than most of the commercial tools that are out there that are like $20,000 if you know how to use them. Burp is amazing. It's a fantastic tool. It also has a community or free edition that you can use. It doesn't have the automatic vulnerability analysis, but a lot of the kind of basic checking that you need to do is built into it. By default, it doesn't have a place for the community version where you insert a UL and have it scan. The commercial version does have that capability. It is very, very, very cool, but it does cost. The one that we're going to be talking about is ATT&CK proxy. It's free. It's very similar to Burp in the setup as a proxy and its setting configuration. It's free. Has a huge development core of a whole bunch of people in OWASP, even though it's now managed by another organization. Lots of people develop and help support this project. It's free. Has the ability to intercept and modify a variety of requests going through it. It's free. Has the ability to do automated scanning, automatic crawling, and automatic scanning. And did I mention it costs you absolutely nothing at all? Yes, it is free. Is it in your budget? Yes, it is in your budget. It's free 90 free. If you want to see what it is with tax, you should use it, right? So all of this kind of goes into the idea of we want to get caught, right? We want to get caught and we want to see the vulnerabilities that were identified. And we also want to see what the organizations are able to detect. So what we're going to do now is we are going to do a lab, and we are going to do the intro lab. Go back. We are going to do web testing right here, web testing. All right, in this lab, we're going to set up a very simple Python web server. You're going to become root on your Kali box. You're going to go into the opt web testing directory, get your Linux IP address, and then you're going to start damn small vulnerable web app. It is the lightest weight vulnerable web app server I could possibly find with a good number of vulnerabilities in it. It's all killer, no filler. It doesn't look good. It's just straight black and white, but it's awesome. And then we're going to start ATT&CK proxy. We're going to run an automated scan. We're going to put in the IP address of our Linux system, :65412, and then we're going to run an attack, and you're going to identify the vulnerabilities on that system, which is pretty cool. It's really small, doesn't take long, but this is the lab we're going to do, and then I'm going to do the walkthrough. Now, we're at the top of the hour. We have 10 minutes, and then after that 10 minutes, I am going to do a walkthrough. So we're going to give you, let's say, not after 10 minutes. After 10 minutes and the lab, I'm going to do a walkthrough. Let's give ourselves 30 minutes for this particular lab. 30 minutes to do this particular lab, and I will come back and do the walkthrough. And then we're going to do Active Directory hardening. And then I've got 2 new labs that I'm kind of thinking about working on. I want to get your opinion. Pretty excited about that. And we'll get rolling. All right, get to it. Let's jump straight into the lab, and we get to the end. We'll chit chat a little bit about it, talk some more. All right, so like I said, we've got to start up the damn small vulnerable web app server. Oops, I should probably, oh, it's not started. So let's go ahead and start this particular lab. So once again, the reason why we have this lab as a separate entity is because we are looking at it through the lens of how do you address web app vulnerabilities aside from the standard, like traditional Nessus vulnerabilities. And we actually have a lab. While that's loading, I can show you an optional lab that you can do. We have this Nessus lab. Like, I'm going to be updating this Nessus lab instead. I'm going to replace it with one where we're doing nuclei, where we do a nuclei assessment, and I have you go through the nuclei results. And we'll talk about setting up and configuring and running nuclei against a bunch of different websites that are intended to be scanned online. There's a ton of them out there. Like, let me show you one that I've used for years. If you go test Acunetics, they have these test websites right here, Acunetics Art. So if you want to go through and try to attack a web server and learn how to attack web servers, test.php vulnweb Acunetics has the capability where you can do a number of different attacks. So I can do a search, do apostrophe or one equals one semicolon dash dash, see if that pulls up anything. No. Oh, but that probably is SQL injection right there. But you have this particular website is a vulnerable website that you can actually try to launch a bunch of different attacks to. There we go. So I was just playing around with the user ID and password right here. And it says you have an error in your SQL syntax. Check the manual corresponds to your MySQL server. For the right version syntax, use and pass at line 1. So let's see if I can actually attack this. Let's do this apostrophe or 1 equals 1 semicolon dash dash. Test it. Not working. Try that in password maybe. But at any rate, there's a bunch of different ways that you can attack this particular web server. No, don't save that password. No, don't do that. But we're going to replace this out. But in this particular lab, the thing that's kind of nice is it has you go through a vulnerability assessment scan report, and it really focuses on you trying to learn what are the low and informational vulnerabilities that you would find on a particular vulnerability scan. Now, in this one, I have the actual answers right here. We have a number of different config terms that are wide open. We have a document that's in here. It's basically passwords.doc and backup.back. These are the types of vulnerabilities that we discover all the time when we're doing vulnerability assessments and trying to break into environments, right? So you can play with this lab if you would like. I'm going to be in the process of updating it here in just a little bit with a nuclei lab instead. And we've kind of switched over to using nuclei quite heavily in what we're doing in Black Hills information security. It's free, it's open source, and we tend to be getting a little bit better vulnerability data out of our nuclei scans than we do out of using something like Nessus. That's not saying you shouldn't use Nessus. It's just saying that there's other tools and there's some free and open source ones that we can actually utilize as well. But when we're focusing on web apps, we're looking at something like test PHP, vulnweb.acunetics. I did have one class where we ran a Z-attack proxy against the Acunetics art website. It didn't go well. It basically brought the entire site down, where we give it the BHIS hug of death. So this is something you can do on your own, and you can do it on your own time. But we're going to focus now on the web app security assessment side of it. So we're going to fire up our Guacamole instance. We're going to log in to our server. And the first thing that we're going to do once we get into the Windows Server 2022 is we're going to fire up our Kali instance, configure that server so that we can start running a scan against it. Now, once again, this damn small vulnerable web is a very, very, very small Python web server, but it does have a number of the different vulnerabilities that you should be comfortable with if you want to get into web application security testing. So we're going to accept that key fingerprint change on that. There we go. And I'm just going to start following the directions. The first direction I'm pretty sure is get the IP address of the system. So I'm going to go ahead and do ifconfig. There we go. And then we're going to cd, let's go into the web testing one right here. And then we're going to cd into the opt web testing directory. So I'm going to take that command and we're going to copy it. Like so. There we go. And then we're going to start the web server over here with Python 3 damn small vulnerable web server. Copy it, paste it on over. Like that. There we go. Now it's running. Awesome. So I do need the IP address of that system because now I'm going to fire up Z-attack proxy. And Z-attack proxy, every time it starts up, it's going to go through the process of trying to update its different services. So just give it a second for it to fire up. I think we have a lot of systems that are being used right now. Go. Waiting. You know, I've learned with the Z-attack proxy, I'm like, well, maybe I should double click it again. Okay. Now I probably have two of them starting. And as I said, Z-attack, oh, there we go. Here we go. Starting up. automatically reaches out to the internet, and it's going to pull down some updates. See if we get another one starting, which happens to me like all the time. All right. So I guess the editors, we can take a break while this is loading, because we can create kind of a cut in the stuff. So do you guys have any questions about the labs while we're waiting on the server to start up? And yes, we're talking about permission. There are some people talking about permissions, and always get permission before you do any testing. There's a number of different websites that are available. One of them is like Juice Shop from OWASP is a good one. That we like that one. We use that in BB King's class as well. So you can go and hit the Akinetics one. This one that we're running is just a standalone individual system that we have. So, all right, go ahead. It's going to pop up here, I think, one more time for some more updates. So we'll just give it a moment. There we go. I think I just closed that right there. All right, so right, editors, we are back. All right, so the first thing that we're going to have to do is we're going to have to click the automated scan. And then we're going to put in the IP address of our Linux computer system. And we are going to go ahead and scan the default port of the server. So we're going to scan 10.10.10.240.139. So we're going to go ahead and put that in over here. We're going to go 10.10. Did I miss a period there? Let's go 10.10.240. What was the last part of my IP address? It was 139. Let's get that 139 in there. 139. And then we're going to put in the colon, and we're going to put in the port listening on that system, which is 65412. So we're going to put in a colon 65412. And now we're ready to start scanning. Now, whenever you kick off Z-Attack Proxy, the first thing it's going to do is it is going to attempt to crawl the entire site to identify all of the different pages that exist. You can see that crawler kicking off down here. So let me grab this and let's make this a little bit higher. So it's crawling the website now. Pull that up. There we go. And we can look at the spider, and you can see there it's identifying all of the different URLs. And now it's going to start an active attack against all of the different pages that it identified. So we're seeing it run that attack, going through step by step by step, trying to hit up as much as it can. And I kind of like this because it's showing you what the actual attacks are. Like when you're seeing %2f, 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 it's trying to do directory traversal, %3a, %2f, other ways of trying to do directory traversals with different types of encoding and things of that nature. So we're seeing those attacks go again and again and again. And if we want to see what vulnerabilities it's actually discovered, you can click over here and you can look at alerts. And it breaks up all of the different types of attacks that you have out there where we've identified cross-site scripting. So we have 2 instances of reflected cross-site scripting that were discovered. And one of the coolest things about this is you can actually look at the request and you can look at the response that was sent. So for this particular vulnerability, we can say this is the request that it sent. And you can see that cross-site scripting attack is right here. And then you can look at the response, and then it's going to highlight what in that response makes it think that it found that vulnerability. You can see that that script alert was actually reflected. And then down here, Z-Attack Proxy gives you a full write-up of what that particular vulnerability actually is, right? So that's pretty cool. Path traversal, this one's kind of fun. It's trying to gain access to Etsy password. We can look at the request and it says, we got the IP address, then we have a path parameter here. Let me zoom in on that so it's a little bit easier for you guys to see. We got a path parameter, %2f is just a slash. And then it's going to go to Etsy, %2f, nether slash, and then PASSWD. Now, if I want to see if that actually worked, I can select response. And sure enough, you can see that that directory traversal vulnerability worked because it dumped the contents out of the Etsy password directory, right? Remote file inclusion, same thing. It's just saying these are the files. The SQL injection is super cool. because within the SQL injection, you can see the request and you can see the response. And you can see right here, we know that we have that vulnerability because you can see SQLite 3 operational error. Anytime we put anything into a web server and you can see that the actual SQL database is responding back with a specific vulnerability, you're pretty sure that you have a SQL injection vulnerability on that particular system. So it's got standard SQL injection, and we have another SQLite error as well. So this is truly the beginning of you trying to identify what are the vulnerabilities that exist on a particular web server. And once again, this is something that is a little bit more than what you would do or what you would get out of a traditional vulnerability scan using something like Nessus. And works well. Like I just really happy with this tool. All right, so now let's go back to our slides here. We do it. There we are. Now, as I mentioned before we went into the lab, one of the key goals that we want to be working with when we're looking at a slide like this is we want to make sure that we get caught. And on this slide, this is one of my favorite like memes online ever. There's nothing quite like a wonderful, amazing picture, a tender-hearted moment between a puppet from Sesame Street, in this case it's Grimace, and a child hugging said puppet, and it actually looks like the puppet is eating the child's head. I love it. That's what the internet is for. That and cute pictures of puppies and kittens. You just can't beat that. Or baby goats. I can't get enough baby goats. They're absolutely awesome. So we want to get caught. And the reason why we want to get caught is we want to create a gap analysis within the MITRE attack technique matrix that corresponds to the stuff that we were doing with things like Atomic Red Team. Atomic Red Team will run a bunch of post-exploitation techniques in the purposes of identifying what are the techniques in the MITRE attack technique matrix that can successfully be detected and which ones can't be. The same thing has to be on the inverse side when you're running vulnerability scans, running web app scans, running attack methodologies in an organization. You want to go through and you want to go through. I'm sorry, just somebody just hit me out of the blue. That Grimace is McDonald's and not Sesame Street. That is absolutely correct. I got that wrong, but it's been a long time. It's been a long time. But we want to get caught, right? We desperately want to get caught so that we can identify what actually works. And this is one of the big problems in information security today. Huge problem in computer security is constantly trying to prove that you can hack something, right? And I'm getting less and less interested with that whole can you be hacked type problem. And I'm now far more interested in what can organizations actually detect, right? We need to move away from that can we be hacked idea because the answer is always yes. Like you can always be hacked. And then you have to move to what can we actually detect. And one of the cool things with MITRE, what we saw with Atomic Red Team and what we have seen with like the vulnerability analysis and how we're attacking web apps and we're attacking things with Nessus is we can run those attacks and we can create a really cool gap analysis and say, what are our detection coverage holes that we can then go to management, show them we have a quantifiable hole, and then what is it going to take from a financial perspective to actually address that vulnerability? Find those gaps, fill those gaps, and once again, starting with MITRE is great. So we did ZAP. Now, kind of the last section of the day is Active Directory hardening. And we have two separate labs that we're going to do, and I'm going to walk through kind of setting up both of them. Both of them are kind of like scavenger hunt labs, and both of them kind of deal with some tools that we use in our own company to assist with organizations trying to lock down their environments. So one of these tools is Bloodhound. Bloodhound is a great tool that identifies multiple pathways to get to domain administrator. And that's fine, and that's good, and that's wonderful. However, the downside of Bloodhound is its primary goal and objective in life is not to give you, a systems administrator, a work list of things that you need to address and you need to fix in your vulnerability kind of roadmap profile. So just really there to get an attacker to domain admin. But the problem with it is multiple different vulnerabilities have to be leveraged in a chain to get to DA. That means that there's actually multiple vulnerabilities that are not part of that direct chain that need to be addressed. And this is also part of one of the classes we have. It's Defending the Enterprise and Applied Purple Teaming by Kent and Jordan. Some amazing classes that you can check out where they get into a lot more detail on this. And we're going to be using one of their tools in this lab that's coming up here in just a little bit. Oops, let me get my cursor over here to the right place. There we go. So this tool is Plumhound. And the goal of this tool is to take that Bloodhound output and give you a list of all the different vulnerabilities and all the different things that can be utilized to identify the pathways to get to domain administrator. So we're going to go ahead. I got Plumhound data that's loaded on the VM. We're going to extract that data. We're going to look at the report, and I'm going to ask you some questions. The questions are relatively easy questions to answer because most of the pages and components of Plumhound are very much in line with what we actually do when we're looking at it. So we're looking at domain users, Kerberoastable users, workstations with RDP, group policy settings, domain administrator settings. All of these different things are part of the output of Plumhound. There's what it looks like. So you'll be seeing this here in just 2 shakes of a lamb's tail. Another tool that you can run is Mimikatz. Not necessarily really a tool that people truly understand. There's a lot that Mimikatz can do. It can extract clear text passwords out of memory, has the ability to pull down password hashes, gives the capability of doing Kerberos token authentication, but there's a lot of other things that Mimikatz can do that you can actually implement in your environment as well. The other thing that we're going to do in this next lab that's coming up is Pingcastle. We have a sample report that's provided by Pingcastle where you just go through the report and I'm going to give you questions. It really, with this next lab is I'm going to give you some questions. You're going to go through the report, see how the reports are structured to answer those questions. And when you answer those questions, you're going to answer those questions on Discord for all of your students. You're going to find out the tools are incredibly easy to parse the output data. Also running these tools, they're super easy to run on an environment as well. And when we come back, we're going to close out with active defense and cyber deception is kind of setting up my next class. So let's go ahead and let's set up both of these labs. So I'm going to connect back into my Windows system. I'm going to go ahead and I'm going to close out Z-Attack proxy, right? Shutting down. And then the other thing that we're going to do is we're going to look at this report. And I'm going to put this report inside of Discord. This is the example report that has been provided by the people at Pingcastle. And it gives you a bunch of Active Directory indicators. And by the way, this Active Directory environment is in a bad state, like really incredibly, horribly bad state. I cannot stress how bad this is. I also want to stress that this is actually pretty normal. When you're looking at Active Directories and you're looking at domain controllers and you're looking at a lot of these different things, I may have talked about this earlier in one of the sessions, but I want you to imagine a snowball. And as that snowball rolls, it gets bigger and bigger and bigger. But instead of snow, I want you to think of it as crap. Like there's literal crap. And every year it rolls, it just picks up more and more crap and it gets bigger and bigger and bigger. And it's just a big old ball of poop, right? That is domain controllers. Every year people make a whole bunch of different group policy. Think of a dung beetle and you're getting really close to domain administrators and what they have to deal with. They're going through every single year and they're adding in new group policy settings. They're adding in new users. They're getting yelled at by administrators and management about all the different things that they're doing wrong. And to do it right would be a terrible burden on other administrators and developers and on management. So just give them full access to let them do what they need to do because you're slowing down the business. I know I'm probably triggering a few administrators right now, but that's literally what happens when you're working in a domain administrator environment, right? So even though this is an absolutely horrible situation, what we have here in Pingcastle, we see this a lot. We go into environments whenever we're working backwards to setting somebody up with our security operations center. One of the first things we do when we're onboarding our customers is we do a full Active Directory analysis using these exact tools. Also looking at Graph Runner for cloud configurations as well. But we go through and we work with our customers to clean up their Active Directory environment before we actually get completely onboarded with that customer. We go through, we run Plumhound from an unprivileged user and an unprivileged workstation, and then we work with them to clean up all of the different vulnerabilities that are discovered before we get them completely onboarded. Now, I want you to think about this in terms of why. Why would we do all of this extra work to onboard our customers in our security operations center? And to be fair, I have customers periodically on the security operations center who reach out to me and they say, oh, well, how much would it be a discount if we don't do the Active Directory hardening? If you're not going to do that, how much cheaper will your SOC be? And I tell them it's going to be double the cost. And they're kind of shocked by that. They're like, wait, you're going to charge us more by doing less? Absolutely. I'm going to charge you twice the money if we're not going to do this. And the reason why I say that is because if we go into our customers' environments and we clean up the customers' environments, we take care of these red things, we start cleaning up the poop that keeps accumulating year after year after year after year, then the likelihood of a breach in that organization leading to a catastrophic compromise of the entire domain environment goes down significantly in organizations. If we go through the Plumhound output from Bloodhound and we address the pathways to get to domain administrator, we're now reducing the likelihood of a ransomware event going from a standard workstation to taking over the entire environment all in one shot, right? And just like today, I had one of my friends, let me see if I can find it here. I had one of my friends that was talking about a number of different attack threat actor groups are doing a number of different three-way tactics. They're going through and they're using encryption, they're stealing files, they're going after the domain controller, they're doing all of these different things to basically have multiple ways to ransom an organization. So the organization can't simply just go through and turn on, like backups. So we clean this stuff up. So now on working incidents, we may find a workstation that is compromised, then we can address it faster. Or more accurately, it's contained for longer and it buys us more time to deal with it. So I'm going to pop up some questions here in just a little bit for Pingcastle and for Plumhound. Now, Plumhound, we have sample output kicked out here on your VM. So if you can follow me, we go to this directory. We're going to go open up File Explorer. All right, so you should all be with me. We go to File Explorer. We go to Downloads. File Explorer, then Downloads. And then you have this directory called Sample Reports. You're going to right-click on Sample Reports, and you're going to 7-zip extract to Sample Report directory. I'm going to give you all a few minutes to get caught up with me. So we're going to extract the sample report zip file into a folder called Sample Reports 1. It's going to be a folder. It's going to save it. We're going to do 7-zip extract to sample reports just in the current directory. Nothing getting cute. All right. So we're going to do that. Download sample reports, extract it to this directory. Take a couple of seconds, pops it up. And then we're going to open sample reports. We're going to go to the reports folder and you're going to go to index.html. Oops, I just passed it. There you go. Index. There we go. All right. Now there's a bunch of different polls, like different reports that are in here, but I'm going to have you go ahead and answer some questions. So we got some questions for Pingcastle and we have some questions for Plumhound. All right. So let me bring those questions up now. Here we go. I'm going to set this up right here for you. think I'm going to take this and we're going to make our font smaller. There we go. So I want you to answer these questions, and I want you to answer these questions in inside of Discord and screenshot what you find, and then do a quick explanation of what these things are. All right. So let's go through. In Pingcastle, are there any systems with empty passwords? So you go to that Pingcastle file and answer that question. Any accounts with passwords that never expire? What does everyone and anyone mean in Active Directory? Any everyone privileges? Any old passwords? Plumhound, are there any Kerberostable users? Any systems without lapse for randomization of the local administrator password? Which accounts have passwords that never expire? And then anything with passwords not required, and then any users with passwords in their description. All right. So we're going to spend, let's just say we're going to spend with the break and everything, we're going to put 35 minutes on the clock, and I will resume. And you guys, when you get the answer, screenshot it and share it with people in Discord. We're going to work on this together, right? So I want you guys to put in the answers to these questions in Discord and where you actually found them. All right. And then when we come back, we're going to do kind of the closing ceremonies for this particular session. All right. So let's get to it. If you need anything, please hit us up. So we have some good write-ups, systems with empty passwords. I like how you're putting in the spoiler thing in it. We have going into the Pingcastle data. What is this one? Check for all admin passwords are changed in the field. We got the full write-up, and we get a list of all the accounts dealing with that, which I think is cool. So let me zoom in on that right here. So we can see we got wrong account 8, wrong account 5, wrong account 1, test ITB, because we see that all the time where we have IT systems that are test environments, and people do all kinds of crazy stuff. Which accounts have that never password expire? Now, okay, so if you're looking at this, just kind of running through this, you totally could have a scenario where the certain accounts would never expire, right? So if you're looking at like Sysmon service, NX log service, those are service accounts, which by the way shouldn't be in the standard user OU, but that's a whole nother conversation. But if you look at it deeper, you can see there's more than service accounts here. We have actual users like Ella, Misha, C, Lincoln, B, Cleaver, B, Haran. We have a number of different user accounts. Now, why would we be in a situation where people would have their user account and their password never expire? Like, what would be the reasonings why we'd actually see that? I mean, if you think about it, we see that a lot with like executives that are too special, right? So we have a number of accounts where the passwords never expire. Anything with passwords not required, guest, anything with passwords in description. That one's kind of funny, right? Because we see that more often than not whenever we're using tools like LDAP Explorer, where we go through and we dump out all of the different user accounts in an environment, and then we pull down the LDAP information, and it happens, right? You see it in the description. Their password is in the description. I can understand how that happens from a technical perspective, right? Like they add in the password in the description and maybe they got to change it. Maybe an administrator is going to change it. But the reality of that happening is still something that blows my mind. It just absolutely blows my mind that that is a thing that people actually do in an environment as well. So here we got really nice write-ups of the accounts with passwords not required. What do we got here? Plumhound answers. Really nice screenshots. I do like call out arrows, by the way, when you're doing the write-ups, but pretty cool. I like that. This is the first lab that didn't feel like a bad dream when you're back in high school and you didn't study for the test, right? It's a little bit easier, right? It's a little bit easier going into these. I don't know which one that is. Password never expires. So using those kind of spoilers, just a great job, great write-ups of all of these things. I like this. System Ella, and just so I don't forget my password, here's the password. Oh my gosh, how does this happen, right? How does this happen? All right, so let's go ahead and let's finish up the slides for today. And we're going to pop out and we're going to do kind of the closing ceremonies to close out the day. Okay, here we go. But I'm hoping to turn this into a full-on, these two things into full-on labs, two separate full-on labs for everybody to work with here in the near future. And I don't know why my slides aren't loading. There we go. We had Ping Castle. That looked good. There we go. Now we're getting it. All right. So this is kind of an opportunity for me to talk to you about the other class that's going to follow this one, which is the cyber deception class, to close things out. In this class, we talk about how to set up a whole bunch of traps and pitfalls for attackers whenever they come into your environment so that you can detect them much faster. And we love this when we see this in our environment. I just got off the phone with a customer who had a bunch of cyber deception all over their environment, and I love it. I love it, right? I think it's like the coolest thing ever when we see it. So here's an example of one of the labs where we talk about how we can create an administrator account that has 0 logins, so login hours. So it is an account that is an active account, but there's no way that you'll ever be able to log in because the login hours are blanked. And we get this in our reports. And like I said, I just got off the phone. We're going to be putting this in one of the reports of our testers. Multiple hosts in this domain were installed as traps. Activities conducted by BHIS reveals these traps were vulnerable to multiple insecurities, and they made tempting targets. Any interaction with these hosts triggered alerts to the customer. We've reported to the test. They should not be relied on for sole source of protection. They provide an added layer of defense. So we also talk about tools that we create custom here at Black Hills Information Security, like Honey Badger. We show you can compile the code and you can get geolocation if an attacker actually downloads and runs that element, where we can get that geolocation in just a matter of like 25 to 70 meters of where the attacker is. So please look at this as an opportunity that you can implement cyber deception in your environment. And this is what it looked like in one of the environments where we set up geolocation. 2 weeks at a very large international bank, we were able to see all of these people that were attacking and gaining access to things they never should, right? And ultimately, this class is designed to get you up to speed for threat intel, but doing threat intel in such a way that it provides value, not about an attack that happened in another organization a month ago, a week ago, a year ago, but getting threat intel through the use of deception on what an attacker is doing right now in your environment while they're trying to break in. So we have that. And yeah, we use this all the time at Black Hills Information Security. This came from us. I think this was last year, where we saw a number of attacks coming from the Netherlands, and they were all going through, and they were all coming from the same place. They were hitting all of our different cyber deception systems, and we were able to identify and geolocate and blow those things out of the water. All right. So I want to kind of close out at this point with kind of where we're at in the class. And I want to say, number one, I want to say thank you so much. I want to say thank you so much. So editors, if you're here, we can cut all of this stuff out. This is just the closing session of the session for this particular class. But I want to say thank you so much to all of you for attending and making all of the sessions throughout this week. I also want to call out like this pay what you can model and what we're doing. We're calling it like pay it forward. We are going to be setting up a Patreon for this because we have people that come through. I'm going to talk about payments here in just a couple of seconds, but I want to kind of say, no, this isn't going to be recorded. The editors are going to cut this out. This is just us right now. This is just us. I do want to kind of throw some things out really quick. And I want to start by saying thank you so much for the people that paid for this class. There's a number of people that looked at the option, looked at the website. They realized that 0 was an option, and they chose not to take that option, and they paid when they totally didn't have to. And if we could get a round of applause through Zoom and on Discord saying thank you to those people, because it does cost us money to put this stuff together. It doesn't all run with hopes, dreams, butterflies, and unicorns. We actually do need some money coming in and making this happen. I also want to call out that the people that paid for this class really are kind of flying in the face of everything in this training industry, right? I came from one of the most expensive training organizations on the face of the planet, and really proud of it, and the instructors and kind of what we did there. But, after a while, it kind of becomes clear that the goals and motivations aren't necessarily helping people. And the goals and motivations aren't necessarily trying to make a more secure world. The goals and motivations become absolutely financially based incentives in a number of different training organizations. And I'm going to say it's impossible for you to be patriotic if you're making like a 95% profit margin off of the United States government, right? That makes me angry, right? You just can't do that. So when we're looking at this class and the people that paid, I really truly appreciate it from the bottom of my heart. Always be looking for the helpers. Always look for the people that have their hands out to give and not their hands to take, and continue to take and continue to take. That's group one. Group two. The second group of people are the people that did not pay to be here. And I'm not going to be some televangelist to be like, well, if you could just find it in your heart. No, I'm going to take a different tack. There's a group of people that chose not to pay and come to this class. And that doesn't mean that they didn't pay. I understand deeply what it's like to live in a household where everything in your life is hourly. The hourly wage that you make while working at a restaurant. I came up in restaurants. My mom worked in food service. The hourly wage that you make working on a construction site. The hourly wage that you make working in retail. The hourly wage that you make doing DoorDash or whatever it is that you're doing just to make ends meet. And when we're looking at that hourly wage, we're looking at that hourly time that you have. That is what you are giving to the universe, is your time. Everything makes you an hourly employee, and everything is based on your time. And I understand that for people that live in that universe, the time that they have is the most precious thing that they have in the universe. And those people may not have paid with dollars and cents, but those people paid with their time that they could have spent going out and spending more time with their kids, time that they could have spent relaxing and trying to get their head, their heart, their body into a better space so they can continue working. And the fact that they chose to spend that precious time with us means everything to me. For a period of time when I was growing up, I grew up in a house that was probably about the size of this studio. It was relatively small. Let's just leave it at that. We had a firewood stove to keep us warm because we couldn't afford the electricity to turn it on all the time. It was basically, the temperature was kept just barely above freezing. If we wanted anything warm, we had to literally go out, get firewood, cut it, and put it in the stove and burn it. I had shoes as a child that I had to duct tape together to wait until my parents had enough money in some situations to buy me new shoes. I get this. I understand this. And it wasn't a fact that my parents were lazy. It wasn't that my parents were slackers. They were incredibly, incredibly hardworking people. And they were brilliant people. And they busted their ass to give us the best possible childhood that they can. And every time that we are teaching these classes and we're doing Pay What You Can, we have people from all walks of life. We have people that come into this class that are working 2 jobs just to make ends meet. We have people that are working in trucking for whatever reason. We got big in the trucking industry. And we have truckers that are listening to these classes, learning these skills so they can get out of trucking and get into IT. And I have people that come up to me all the time. Last week at Right at Boom, I had a dude come up to me and he said, look, your classes of what you do at Antisyphon, your classes allowed me to get a job to where I'm now working in a security operations center. I now have a good job. I'm providing for my kids. I had one lady that came up to me and she said, I got a job in computer security based on the training that I did at Antisyphon. And shortly after I got that job that had full insurance, I found out that my kid had cancer. It was a survivable cancer, but because they had health insurance, they had the ability to treat that cancer with the best possible care that they could. And that is what drives all of us at Antisyphon. Coming up with affordable training that we can do, that we can provide to the community, that we can get out there and try to make the world a better place in a little way. And this all started, I want to make it clear how this started. And this gets into some of the conversations of things that are happening, but I want you guys to listen because I think that this is important. When this all started, we originally were talking about, can we do scholarships for people that are underrepresented in computer security? And we were talking about scholarships for African Americans. We were talking about scholarships for women. We were talking about scholarships for different groups, and we were discussing these different things. And I need to make this clear, and it's going to come across as harsh, but stick with me. I hate that. I absolutely hate that. And the reason why I hate that, even though it's wonderful for the people that get it, it doesn't fundamentally change the damn game. It doesn't actually change the industry. It doesn't actually change anything. And seriously, when we looked at that and we said, instead of doing a handful of scholarships so we can have a photo op and be like, look at us, we said, how can we fundamentally burn the gates down? And that's where Pay What You Can was born. Because we don't care if your ethnicity, your race, your religion, your gender orientation, we don't care where you're from, we don't care your socioeconomic status, we just want you here. We want you to be able to enter this amazing industry that has amazing barriers to entry that, yes, may manifest based on race, that may manifest based on gender, but all of them are driven by one thing, and that is money. So by taking money off the table, making it pay what you can is what we are trying to do to make this industry look a little bit less like me. Because I got to be honest, I get bored hanging out with people that look exactly like me. And I get energized every single time I talk to people who had that opportunity. Because if you sit down and you talk to people that are disadvantaged, they don't want a handout. They want a goddamn opportunity, and they want equal playing fields, and they want equal opportunities to come in. That's all that they're asking for. And that's what we're trying to give. That's what we're striving to give with what we are doing at Antisyphon. And with that, I have one small request for all of you. One small request. It's a simple request. Help us amplify the signal. Help us amplify what we are doing here at Antisyphon, what we are working on at Antisyphon when we are doing these classes, when we are pushing these things out to the community. Help us amplify, because we want more help reaching those people that are working 2 or 3 minimum wage jobs just to get by. We're looking for those people that may have gotten pregnant early on in their careers and college was absolutely not an opportunity, or they come from a part of America, whether it's the inner cities or whether it's Appalachia or whether it's the Black Hills of South Dakota. They just didn't have a financial opportunity to go to college and enter into the life that a lot of us take for advantage. Help us amplify the signal, because you know somebody. I guarantee it. You know somebody that has the technical aptitude. You have somebody that has the skills. You have somebody that has the need, and all they need is the opportunity, and we're going to give that opportunity to as many people as we possibly can. And with that, I want to say thank you so much. I can't wait to see you in another class. I can't wait to see you all at a conference where you have the opportunity to come up and tell Jason, Megan, Deb, all of the people that are part of this community, Zach, I could go down a huge list, but you have an opportunity to come up to us and tell us your story, because those stories are what sustain us. Those stories are what make us grow and continue to push the boundaries of what a company can do when actively trying to help the entire industry. So with that, thank you so much. I hope you have a great week, and I can't wait to see the beautiful things that all of you will do. With that, get out of here. I'll see you all later.